Okay, balancing equations. This is what we worked on Tuesday when we came back from the break. Balancing equations. All equations must be balanced. This is the law of the conservation of mass. We began this learning about the law of conservation of mass back in September when we were balancing them. If we had 15 grams on my reactant side, I needed 15 grams on my product side. Okay, so balancing chemical equations. Remember, if I highlight something, then that means you need to come to class knowing it. Balancing a chemical equation means we have the same number of each element on both sides of the equation. Therefore, the mass is equal. Okay? So if we have the same number of each element on both sides of the equation, we are following the law of the conservation of mass. That's a TEK. You need to know it. Two things to remember when balancing an equation. This will be the second time we've written that. That means it is very important. We only change coefficients. And we never change subscripts. Very important for both. How to balance a chemical equation. Not every formula needs a written coefficient. If there is no coefficient in front of the compound, it is understood that the coefficient is a 1. Again, that's the second time we have written that, so that means it is very important. If a polyatomic ion is present on both sides of the arrow in an equation, balance the polyatomic ion first. Never separate if it's on both sides of the equation. If it's only on one side, we will have to separate it. We're going to balance hydrogens and oxygens last. And number 4, if hydroxide is on one side of the equation and water is on the other, rewrite water as HOH. So if hydroxide is on one side of the equation and water is on the other, rewrite water as HOH. All right? Coefficients, we're going to multiply everything, just like in math. Multiply everything in the formula. For example, if I have 4 CO2, this means I have 4 carbons, and 4 times 2 is 8 oxygens. Okay, if I went too fast, pause it, write the stuff down, and ask me questions. All right, so let's practice. Number 1, we're going to start by balancing balancing polyatomic ions first, then metals, and move across the periodic table. All right, we'll come to number 2 in a second. All right, lithium, lithium, oh, I'm so sorry, you couldn't even see that. So number 1, start by balancing the polyatomic ion first, then the metals, and then move across the periodic table. So lithium, I have 1. I have 1 here. I have 2 chlorines here, and I have 1 chlorine here, so I'm going to put a 2 there. Well, now that just gave me 2 lithiums, so I place a 2 here. Could I put it as a subscript? No, because never change the subscripts. Let's balance mercury 2 oxide. All right, 1 mercury here, 1 mercury here. I have 1 oxygen here, but 2 oxygens here, so I need to put a 2 here. Never put a subscript. So now I have 2 mercuries and 2 mercuries. All right. So step 2, we're going to underline the polyatomic ion if it's on both sides of the equation. All right. So I remember if I have a polyatomic ion, that means I have more than 2 capital letters. I have just 2 capital letters here, so no polyatomic there. I have my polyatomic here and here. Remembering that a parentheses means I have more than 1 polyatomic ion. So let's balance that first. I have 2 aluminates here, so I put a 2 here to give me 2 aluminates. That gave me 6 sodiums, so I put 6 here because 2 times 3 is 6. Now that also gave me 6 chlorines, so I put a 3 here because 3 times 2 is 6. That gave me 3 irons, and I have, oops, I forgot, I'm so sorry, there's 2 typos in this paper. That is 1. I have 3 irons and 3 irons. I did not add that as a subscript. That was a typo. Please pay attention to that. All right, step number 3 tells me if I have OH on one side and H2O on the other, comma, rewrite water as HOH, underlining that hydroxide. Okay, so we have a polyatomic here and the same polyatomic there. I have hydroxide here and I have water here, so I'll rewrite it as, whoops, I just about rewrote it as water. Can't do that. So I rewrite it as HOH and underline the OH. All right, so we'll start by balancing that. I have 2 hydroxides here, so I need a 2 here. All right, go into the next polyatomic. I have 2 phosphates here, so I need 2 phosphates here. But be careful, that just gave me 2 times 3 is 6 hydrogens here, so I need a 6 here. So I have 6 hydrogens. Now that gave me 6 hydroxides. So I have to put a 3 here, because 3 times 2 is 6 hydroxides. They gave me 3 calciums, and I have 3 calciums, so is now balanced. Okay, number 4, if a polyatomic ion is only on one side, break it up into its parts. Okay, so I have a carbonate here, but I don't have a carbonate here, so I needed to distribute that 3. 3 times 1 is 3, and 3 times 3 is 9. I put them separate so I can see that they go with separate elements. So let's start by balancing our metal. I have 2 aluminums here and 2 aluminums here, so that's balanced. Now let's go with our carbons. I have 3 carbons here, and I need a 3 here. So that gave me 3 times 2 is 6, plus those 3 is 9 oxygens, so it's balanced. Okay, on to the next one that we practiced in class today. We write water as HOH because I have this hydroxide here. I have a phosphate here and a phosphate here. So there's 1 of each polyatomic ion, so I'll move on to my metal. I have 3 potassiums here, so I need a 3 here. This gave me 3 hydroxides, so I'll put a 3 here. They gave me 3 hydrogens, and I have 3 hydrogens, so it's balanced. On to the next one. We have a hydroxide here and a water here, so we write it as HOH, underlining our polyatomic ion. So I have 2 hydroxides here, so I need a 2 here. I have 2 hydrogens here, so I'll put 2 hydrogens there. That gave me 2 chlorines, and I have 2 chlorines. All right, we're going to skip this one. You will not have to do one like that, where we have to break up the polyatomic even though it's on both sides. So let's go ahead and just skip this guy. All right, I have a hydroxide here, and a water there, so I'm going to rewrite it as HOH. I have a sulfate here and a sulfate here, but be careful, I do not have an ammonium on this side. I have an ammonia, two different things. So I need to break up this ammonium. 2 times 4 is 8, and 2 times 1 is 2 nitrogens. So let's balance our polyatomics. I have 2 hydroxides here, so I need a 2 here. Remember, we're going to do our hydrogen last. So I have 1 sulfate here, 1 sulfate here. Moving across the periodic table, I have 2 nitrogens here, so I need a 2 here. That gave me 2 times 3 is 6, plus these 2 hydrogens, that's 8 total hydrogens, and I have 8 total hydrogens there. So that one's balanced. On to the next one. Remember, pause the video if I'm going too fast, so that way you can work these out. Alright, so we're going to move on. We'll balance our carbons first. our oxygens. I have 3 and 1 is 4. So that means I'm going to have a 2 here. The reason I'm balancing those first is because this is by itself and it's easier to change. Alright, so now it gives me 2 times 2 is 4 carbons. So I need, 2 times 1 is 2 carbons, so I need a 2 here. That gives me 2 times 1 is 2. Plus 3 is 5. We can't divide anything by 2, an odd number by 2 and get an even number. So we're going to add 1 more oxygen. So 3 plus 3 oxygens is 6. So I'll do 3 times 2 is 6. 3 carbons, and then finally 2 irons. And we're done. On to the next page. Our last page of notes for today. And we're going to talk about combustion reactions. I have a picture of a candle here. Okay, so a combustion reaction must have a hydrocarbon molecule that contains a carbon and a hydrogen, and we also must have oxygen as a reactant. It must also have carbon dioxide and water as a product. We're going to balance the carbons first, the hydrogens second, the oxygens third. If this doesn't work, if it doesn't balance out, we're going to double all the coefficients that we're using. So let's try it. Okay, so balance the carbons. I have 9 carbons here, so I need a 9 here. I have balanced the hydrogens next. I have 18 hydrogens here, so I need a 18 here, so I'm going to put a 9. Now let's add up all of our oxygens. I have 9 times 2 is 18 plus 9, so that gives me 27 oxygens. Okay. Well, I can't divide that by even and get an even number, so I need to double everything. So this will be 2, this will be 27, 18, and 18. Okay, so we'll work on this in class tomorrow, top, front, and back, and it'll be due at the end of class.